Hi, welcome to the State of Charge report from Focus, all about the battery chemistries of the future. Let me give you a brief rundown of exactly what we found. So we analyzed 25 different chemistries, some of them applicable to grid storage, some of them applicable to mobile phones, but all of them applicable to electric vehicles. And our findings are pretty interesting, actually. So what we found is lithium ion is still king, and it will be king for the foreseeable. It's a great chemistry. We know how to make it. All the production is in place. We know its performance as well. And it's improving reasonably well. It's 30% every single year. So that's performance per dollar improvement. The big surprise for some, maybe not all, is solid state is not going to be the revolution we were hoping it would be. It's reasonable. I think it will be a bit of an evolution that we see with solid state, but it's not going to be the disruptor that some people build it up to be. So pop that bubble. However, there are two really promising upstart chemistries that we're seeing. Graphene and Dual-Ion, both of those improving around 50% year on year in performance per dollar costs, which is hugely impressive. So the question on everybody's minds is, when's it going to be ready? Graphene in particular is, well, it's great. It's ubiquitous. It's carbon, right? Like, there's tons of carbon everywhere. You just got to burn some paper and boom, you make carbon. But making graphene, which is a one-dimensional sheet of carbon atoms, consistently and cheaply is not an easy thing to do at all. So right now, the cost of graphene is about $200 per kilo, which is super expensive. That's like 20 times more expensive than lithium. It needs to fall drastically. And the good thing is we forecasted that as well. So by 2031, give or take a few years, because these are forecasts, we expect it to be on price parity with lithium. And I think that's when we'll really see graphene batteries become commercially viable, and they're going to be in everything. Your car, your fridge, your Apple Pro Vision headset, grid storage, maybe, maybe not. It doesn't have the greatest energy density that we've seen, but for sure it's going to be disruptive. On page 7 of our report, you're going to find a pretty comprehensive table. We've listed all the top categories of batteries, so lithium-based chemistries, sodium-based, metal air, magnesium, aluminium, or aluminum, if you like, zinc. There's lots of other ones. There's flow batteries, which I'd never heard of before this, organic, and then the really exciting ones, the emerging. On each, you're going to find which one's applicable to which use case, and then you're also going to find the technology readiness level, so how many generations before they're commercially viable. On page 10, you're going to see a pretty busy looking graph. Let me talk you through it. On the x-axis, we've got the technology readiness level. That is how many generations away from becoming commercially viable, e.g. TRL level 9, a technology is. On the y-axis, you're going to see the performance improvement rate in performance per dollar terms. And then the size of the circles are indicative of the potential energy density of each battery. In a perfect world, we'd have a TRL level 9 battery. So commercially viable, it's ready, we can manufacture it. It would have a really big circle size, so it would be super energy dense. And then ideally, it would be really high up the y-axis as well. So it would be improving its performance per cost terms really quickly as well. However, that's just not the reality, so what are the next best candidates? If we look at this, silicon anode is really interesting because it's a couple of generations away from being commercially viable. It's improving relatively fast, so around 30% year on year. And it's got a really big energy density capacity. So we could look to utilize it in electric vehicles, in grid storage to store all the renewable power we need to be generating. So that one is one to keep an eye on. Obviously, we've got our two sort of emerging technology outliers, if you like. Graphene and Dual-Ion, they're really high up there, but again, they're a little bit early, so TRL level 4 and 5 respectively, not quite ready. And then we've got solid state lithium, the kind of awkward middle child in the middle. It's improving fine. It's 30% year on year, estimated to be TRL level 6, so a few more generations away from commercialization. But ideally we'd like it up there next to Graphene and Dual-Ion, improving super fast. So that's how to interpret the Disruptor matrix on page 10. So on page 15, you're going to find our company's preview. So we told you graphene is the future. It's really exciting. What can we do about it? Well, you can look for partners, you can look for M&A opportunities, you can look to license technology. We've got another one of those really good disruptor matrices here, this time for companies, slightly altered this time. So we've got cycle time on the x-axis. That is, how long does it take for a company to invent a new generation of their graphene battery? Lower is better here. And then we've got knowledge flow. So how influential is each generation in terms of pushing the performance forward? So again, higher is better here. So nobody's super influential in this. Everybody's sort of clustered around the middle, but we do have a couple of outliers. The appropriately named Global Graphene Group has got a really highly influential portfolio. And again, the size of the portfolio is represented by the size of the circle. Toray, which is a household name in terms of materials, at least in my household. So they're out there with a really quick cycle time. So they're iterating rapidly on their technology. And then in the middle, you've got these kind of a lot of interesting companies. So StoreDot is quite a small company at the moment, maybe a startup scale-up type. That's definitely worth investigating. Caltech is a university that's well known, and yeah, maybe you could partner with them. And then the usual suspects, Samsung and LG, are there as well. So kind of all the people you would expect to see. But then hopefully some new names for you there as well. So lithium ion is great, it's sticking around, but there's definitely room for disruption, and it's coming pretty soon. You can download it freely on our website. Please do let us know what you thought of it if you read it. Did we get it right? Did we get it wrong? We'd love to know. We're going to do more of these, so look out for that to come. And finally, thanks for tuning in. Cheers.